Hello, and welcome to this video on mortgages. We're going to work on a problem that involves a mortgage, and we're going to find information about how much the installments should be to cover the mortgage in 20 years, and then some more information. And to work with this problem, we'll get to use formulas covering some of the content from chapters on annuities and compound interest. So if you need to review those topics before watching this video, please go ahead. If you have watched this video and you have questions, please write a comment or contact me and I'll be happy to help you. I hope you enjoy this video. Consider an example where Kelsey purchased a house for $425,000. She made a down payment of 20% of the value of the house and received a mortgage for the rest of the amount at 5.12% compounded semi-annually, amortized over 20 years. The interest rate was fixed for a 5-year period. We need to work with 3 parts in this question. First, we need to calculate the monthly payment amount. Second, we need to calculate the principal balance at the end of the 5-year term. And third, we need to calculate the monthly payment amount if the mortgage was renewed for another 5 years at 5.72% compounded semi-annually. And in all parts, we need to round answers to the nearest cent. The answer to the nearest cent. All right. To work with this problem, it's important to recognize that the loan is in the form of annuity, and this annuity is an ordinary annuity because payments are made at the end of the payment period, and this annuity is general because the payment period and the compounding period are not the same. The payment period is monthly, while the compounding period is semi-annually. So we need to set some things clear. Let's start by saying that the amount that was borrowed, let's go with green, was 80% of the total of $425,000. So we multiply $425,000 by 0.8 and we get $340,000. That's the amount that was borrowed. And here the number of compounding periods per year is 2. So the periodic interest rate is J divided by 2, where J is the nominal interest rate. Now, because we have different nominal interest rates, like for part A, we have the nominal interest rate equal to 5.12%, and for part C, we have 5.72%, then we're not going to fix J yet. But we're going to say that with the value of I, whatever I is, we can find the effective periodic rate by computing C, the number of compounding periods per payment period. So we have C equals 2/12 because there are 2 compounding periods per 12 payments. So this is 1/6. And then the effective interest rate is given by 1 plus I, whatever I is, to the C, take away 1. Okay. Now let's start working on part A of this problem. Let's find the monthly payment amount that corresponds to this loan, to the payment of this loan of $340,000 amortized over 20 years and the nominal interest rate is 5.12% compounded semi-annually. So here J is 5.12%, or in other words 0.0512. With that value of J, we can find I and I2. I is J over 2, and then I turns out to be 0.0256. And with that value of I2, the effective periodic rate turns out to be 1 plus 0.0256 to the 1/6. That's the value of C. We have 1 plus I to the 1/6, and then minus 1. Okay. Now, in 20 years, Kelsey makes 12 times 20 payments in total. Because Kelsey makes payments once a month, and there are 12 months in 20 years, and Kelsey makes 20 times 12 payments in total in 20 years. So we have 240 payments. And if Kelsey gets to settle the loan, then we have that the value of $340,000 in 20 years. So we have 1 plus I2, so the 240. So it should match the future value of the annuity that we have after 20 years. So we have PMT, and that's the monthly payment amount, multiplied by 1 plus I2 to the 240 minus 1 over I2. So the monthly payment amount should be equal to $340,000 multiplied by 1 plus I2 to the 240, then multiplied by I2. Then we divide all this by 1 plus I2 to the 240 minus 1. We have just solved for the monthly payment amount in terms of I2, the effective periodic rate. And when we use a calculator to compute PMT, we find the following value. We find approximately 2,256.31. That's what we find, so that we can say that Kelsey pays installments of about $2,256.31 every month for 20 years to settle the loan of $340,000. Okay, so here we have the answer to part A. The answer to A is about that amount. We have rounded the answer to the nearest cent, meaning that we have rounded the answer to 2 decimal places. Okay. Next, we are going to work on part B of the problem. So let's move on to part B. And for part B, we're going to use part A, the solution to part A. Okay, we have just made room to write the solution to part B. In part B, we need to calculate the principal balance at the end of the 5-year term. Okay, so we need to find the principal balance after 5 years. To compute that principal balance, we subtract 2 values. We have the future value of $340,000 in 5 years, and after 5 years we have that there have been a total of 60 payments, because we have 12 payments per year for 5 years. That's 60 payments. Okay, so the future value of $340,000 is $340,000 times 1 plus I2 to the 60, and we take that and subtract the future value of the annuity in 5 years. So we subtract PMT multiplied by 1 plus I2 to the 60 minus 1 over I2. And we have written the principal balance in terms of I2 and PMT. We found PMT in part A. We can use a calculator to compute this value for us. Remember that I2 is given by the expression 1 plus 0.0256 to the 1/6 minus 1, and PMT is given by 340,000 times I2. We have a whole expression for PMT, or we can use what we found for part A, 2,256.31. Okay, and when we use a calculator to compute the principal balance, we find that the answer can be rounded off to $284,080.99. Okay, so that's what Kelsey owes after 5 years. All right. Okay, so here we have the answer to part B. Answer to B. Make sure to use a calculator that can handle various variables. So we assign I2 this value, we assign PMT this value, and then we find this expression. Okay, let's move on to part C of this problem. Okay, for part C, we need to find the monthly payment amount if the mortgage was renewed for another 5 years. So that's after the 5-year period. And then, but it's renewed at a different interest rate. We change the interest rate to 5.72%. So now J is 5.72%, or same thing, 0.0572. So now I is equal to the expression 0.0572 divided by 2, or same thing, 0.0286. And then I2 turns out to be 1 plus 0.0286 to the 1/6 minus 1. Okay, so there we have that. And after 5 years, Kelsey still needs to make 12 by 15 payments. 12 payments per year for 15 years. So we have 12 plus times 15, that's 180 payments that remain. And Kelsey needs to cover the amount that we found she still owed after the 5th year, the amount we found in part B. So we must have that $284,080.99 should be equal to the new monthly payment amount then and we forgot but the future value of that amount of money. So we have 1 plus I2 after 180 payments. So there we have, to the 180 equals the new payment amount times 1 plus I2 to the 180 minus 1 over I2. So the payment amount turns out to be 284,080.99 multiplied by 1 plus I2 to the 180 multiplied by I2, all that over 1 plus I2 to the 180 minus 1. And once again, we have an expression that involves unknowns. In this case, just one unknown. I mean, not an unknown actually, just a parameter, I2, and I2 is equal to this expression right here. So make sure to save this number, assign that number, that variable, that number, and then use a calculator to compute PMT this way. And when we use a calculator to compute PMT, we find about 2,344.31. So this is the answer to part C. Okay, so that's the end of the video. We have worked with compound interest and with annuities to solve this problem on a mortgage. If you have questions, just let me know. And yeah, I hope you enjoyed the video. Thank you for watching. Bye bye.